All right, starting it off. Got it, problem number 3, and this is on page 442. So you are trying to figure out, I think, the value of y. And it says these polygons are similar. It says so up in the directions, meaning that the corresponding angles are congruent, which doesn't help me because I'm trying to find the length of a side, but I know the sides are, corresponding sides are in proportion. So I'm going to set up a proportion. And I'm not going to set up an extended proportion, just a proportion. And I want y in there, and y corresponds with 5. And then I'm going to have, I don't want to choose x, because that's variable, so I'm not going to use 7.5, meaning I'm going to have to choose 6 corresponds with this whole side, which is 9. And then I would solve that proportion. The means are equal to the extremes. Products are, so 9y equals 30, divide by 9, and y equals 39, which is improper, which is 3 and 3/9, which is 3 1/3. Done. 3 1/3. All right, got it. Problem number 4. Okay, this one's about actually using similarity, and it's about a poster design. So you are definitely going to need to read through to see what the design is for the poster, because that's given in problem 4, and they actually work through a problem that is similar to it. How weird, similar. So go ahead and do that. Pause the video, try and figure this thing out, people. Okay, because I'm starting. All right, use the same poster design in problem 4. The poster design was what? 6 inches high by 10 inches wide. 10 inches wide. That was the design. Your class is making a rectangular poster for a rally. The space allowed for the poster is now 3 feet high by 4 feet wide. So I'm going to start just drawing some pictures of rectangles. So 6 inch high by 10 inch wide, 6 inch by 10 inch. That's their poster design. And the complete poster will fit in a space 3 feet high. So 3 feet high by 4 feet wide. What are the dimensions that I can enlarge this so that it's proportional, so that it's similar, so that I don't distort it, that it will fit on there. So let's look at the heights. So let's look here. Now they're different units, so I'm going to go ahead and convert them over. So this is the same thing as how many inches? That's going to be 36. This is the same thing as 48 inches. We're good there. And then I'm going to check and see here the height from here to here. I'm going to go ahead and divide those two to see what I get. I can figure that out in my head. Here, that I can multiply by 6. Here, the largest I can go would be 4. So I can't go up to 5 because that would be too much. So the design can be enlarged at most. And actually, you know what? I should actually get the exact amount right here. And 48 divided by 10 is 4.8. So I can multiply by 4.8 there to get 48. And that means I can enlarge it at most by 4.8 times as much. That's what I want to use. Okay? Can't do 6. That's too much because this was only 4.8. So now the question would be, what are the dimensions of the poster? Well, we know we can make it to 48, right? We know we can make it there. So it's going to have a width of 48 inches. And then the height I'll need to figure out, because now I am not going to go to 36 because that's going to be too much. I multiply by 4.8. So if I take 6 and multiply it by 4.8, I should have my answer of 28.8 inches. So there I have it. Okay, one more problem. Got it? Problem number 5, page 443. And this deals with the scale drawings. So in this one, you'll need a ruler. So hopefully you can find those in my room if I forgot to get them out for you. Use the scale drawing in problem 5. So there is a scale drawing there, and you are finding the actual height of the towers above the roadway. Very important to make that note, above the roadway. So go ahead and try and figure that out. Pause the video, and actually I need to pause also because I need to get a ruler to figure this out. All right, see you soon. All right, I am back. I measured and I was exact. You need to be exact on these things. And I measured in centimeters for a reason, because the scale was given in centimeters. Okay, so I'm going to measure in centimeters. So I got this, and that's what you should have gotten too if you didn't look again. And then I'm going to solve it using those products of the means and the extremes. So my x value turns out to be, if I multiply those together, 160 meters. Okay, for part A. Part B, it's a little different of a problem. So if you've tried it, good. If not, pause the video. It says the Space Needle is in Seattle, if you've ever been there, is 605 feet tall. Okay, a classmate wants to make a scale drawing of it on an 8.5 by 11 sheet of paper. Okay, he decides to use the scale. Every inch is 50 feet. Is it reasonable? Well, will this height fit on that paper? So that height is the actual distance. So I'm going to put it down here and check to see if this will fit on that paper, no matter which way I go on the paper. So let's see, the products, 605 equals 50 times question mark, divide by 50. So 605 divided by 50, using my calculator, is 12.1 inches. And is that possible on an 8.5 by 11 inch sheet of paper? No. Okay, so no, because the paper would have to be over 12 inches long, and it's not. So you are going to go to Gunnison Math, and I don't want to see you just stopping now. You take a little mental break of 3 minutes and get a drink or something. Go to the water fountain, get a drink, but otherwise you need to start or finish working, practicing these problems from that section. And you will find the problems at GunnisonMath.com, and those are due on Friday. Okay, if you're following along and getting everything done on time. All right, good luck. Thanks for watching. Have a good day.